Okay, so 9/24/20. This is day 1 trig review. So first of all, when we review trig, we want to review our trig chart. Pi over 6, which corresponds to 30 degrees, pi over 4, which is 45, pi over 3, which is 60. We have sine of some theta, cos of theta, tan of theta, cosec theta, sec theta, tan theta, cotan theta. All right, so here we've got 1/2 radical 2 over 2, radical 3 over 2. For cos, the middle stays the same, or you could think of it, it's the sine row backwards. Tan is sine over cos, so that's one thing we should know. Tan theta is sine theta over cos theta. So radical 3 over 3, 1, and radical 3. That is a radical 3. Okay, cosec is the reciprocal of sine, so you should know that. Cosec theta is 1 over sine theta. So this would be 2 radical 2 radical 3 over 3. Sec theta is the reciprocal of cos. So for sec, we're flipping cos. So we get, or again, you could think of it as cosec backwards. So it's 2 radical 3 over 3, radical 2, 2. And cotan is the reciprocal of tan, or what I think of is it's actually tan backwards. Radical 3, 1, radical 3 over 3. Some other things you're supposed to remember is that all of your odd pi's, so we start here at 0. This is 1 pi. This is 2 pi. This is 3 pi, right? Pi goes 180 degrees. 4 pi, 5 pi. So you should know that your odd pi's are the same as pi, and your even pi's are the same as 0 or 2 pi. You should also know your unit circle to help you handle the quadrantal angles, which are 0, pi over 2, pi, and 3 pi over 2. So this is 1, 0, 0, 1, -1, 0, and 0, -1. And it goes cos theta, comma, sine theta, meaning cos is the x, sine is the y. And we already said that tan theta, which is sine theta over cos theta, that means it would be y over the x. All right, so if we're going to evaluate giving exact values, we also need to know, I can just put this up here, all students take calculus, so everything's positive here. In the first quadrant, in the second quadrant, it's sine and sine's reciprocal. In the third, it's tan and tan's reciprocal. And in the fourth, it's sec, or it's cos and cos's reciprocal, which is sec. Okay, so for example, if we're evaluating sine of 2 pi over 3, what I do is I go back to my chart and I say, okay, what's sine of an over 3? Sine of an over 3, we're right here, radical 3 over 2. So again, we're going sine of an over 3, radical 3 over 2. Now, the one thing we have to determine is that positive or negative? So we have to know what quadrant the angle 2 pi over 3 falls in. So last year, what we often did is we would say, okay, what's close to being close to 2 that's divisible by 3? And we would say 3. So we would say like 3 pi over 3 is right here on the line because it's pi, right? 3 pi over 3 is pi, which means 2 pi over 3 is 1 less than 3 pi over 3. So it'd be second quadrant, right? If you're coming around counterclockwise, you would back up from 3 pi over 3 to get 2 pi over 3. One more would be 4 pi over 3. So if we're in the second quadrant, if 2 pi over 3 is in the second quadrant, sine is positive in the second quadrant, so my answer is just positive. What if we got cos of 4 pi over 3? Well, again, we would go back to our chart. We would say, okay, cos of an over 3 is a half. So this is a half. Then we would determine quadrant. Now I actually already figured that out here. We're in quadrant 3. Cos is negative in quadrant 3, so my answer is negative. Let's say tan of 5 pi over 3. So again, you're going to go to your chart. Tan of an over 3 is radical 3. I have to determine what quadrant I'm in. So this is where we're going to think, we know 3 pi over 3 is here. 6 pi over 3 is here at 2 pi on the line. So if I'm coming around in a counterclockwise direction, 5 pi over 3 is 1 less than 6 pi over 3. So it's in the fourth quadrant. Tan is negative in the fourth quadrant. So that makes my answer negative. That method enables you to do, if you have, let's say, a big number, 37 pi over 3. Again, tan of an over 3 is radical 3. 37 pi over 3, so we want to think of a number close to 37 that's divisible by 3, and it can only differ by 1. So that would be either 36 or 38, so it would have to be 36, right? And then what you want to think of is, where would 36 pi over 3 be? Well, 36 pi over 3 is a 12 pi, which is your even pi. So 36 pi over 3, which is 12 pi, is right there on the right with 2 pi, where our even pi's are. So if I'm coming around counterclockwise, we know 35 is before 36, so that'd be fourth quadrant. 37 pi over 3 is first quadrant. So we're in quadrant 1. Everything's positive in quadrant 1. Now, the key is, one thing is that this method only works if the fraction is reduced. So what that means is, if you had something like sine of 14 pi over 6, I don't want to do the sine of 14 pi over 6 because 14/6 reduces. So I would want to reduce that 7 over 3, because now what I need to realize is this is not an over 6 reference angle. It's an over 3 reference angle. So I would say, what's the sign of an over 3? I'd go up to my chart, radical 3 over 2. And then where is 7 pi over 3? Well, I want to think 6 pi over 3 is here at 2 pi on the line. So 7 pi over 3 is in quadrant 1. Everything's positive in quadrant 1. Okay, we have cos of negative 15 pi over 4. All right, negative angle means to go clockwise around the circle. So if I'm starting here at 0, this would be a negative pi. This would be negative 2 pi. Going this way clockwise, this would be negative 3 pi. So what I want to think about, what is close to 15 that's divisible by 4? That'd be 16, right? Can only differ by 1. So I want to think, where would negative 16 pi over 4 be? Well, negative 16 pi over 4 would be here, right? It would be equivalent to negative 4 pi. If it's negative 4 pi, my even pies are on the right. So that would be kind of where 0 or 2 pi would be. So now keep in mind, though, I'm going clockwise. So because it's a negative angle, so negative 15 pi over 4 is here. Negative 17 pi over 4 is here. So negative 15 pi over 4 is a first quadrant angle, which means it's positive, and cos of an over 4 is radical 2 over 2. So again, you're going clockwise with the negative angle. Now, to talk about how we handle something like sine of 11 pi over 2. The over 2's or the pi's are not in the chart. They're on the unit circle. So one thing you could do is think of this as a mixed number, sine of 5.5 pi, right? 11 halves is 5.5. So if we think about it, okay, we go 0. We know 5 pi, right? Pi, 3 pi, 5 pi are over here. So 5.5 pi, think about a half a pi. Pi over 2 is 90 degrees. So you end up right here, which is the same as 3 pi over 2. So this would be the same as doing sine of just a 3 pi over 2, because that's where it falls, which is 0, negative 1. It goes cos, comma, sine. So sine is negative 1. Let's say cos of 5 pi over 2. Okay, that's cos of 2.5 pi. So let's think of it. 2.5. Here's 0. Here's pi. Here's 2 pi. Here's another half a pi. 2.5 pi is the same as cos of just a pi over 2. Right, on our unit circle, this is where pi over 2 is, 0, 1, which means cos is the x value, so it's 0. Tan of a negative 7 pi over 2. So that's tan of negative 3.5 pi. Okay. You're going clockwise. Here's a negative 3 pi, because all my odd pi's lie over with pi. And here's negative 3.5 pi, right? You go another half of pi. So that's the same as tan of pi over 2, right? Because on your unit circle, it goes 0, pi over 2, pi, 3 pi over 2. This is 0, 1. Tan we know is sine over cos, so that's undefined. And last year, a lot of times we used to say tangent's undefined at the over 2's. So the fact that it was a pi over 2, I kind of should have known that was undefined. Sec squared of pi over 4. That's the same as doing a sec of a pi over 4 and then squaring your answer. So sec of pi over 4 is radical 2. It's positive because pi over 4 is a quadrant 1 angle, right? Your pi over 6, your pi over 4, your pi over 3, those are all quadrant 1 angles. And then you square it and you get 2. Last example, if f of x equals tan if f of x equals tan of x plus pi over 4, find f of pi over 2. So this is tan of pi over 2 plus pi over 4, which is tan of, we need a common denominator. So that's tan of 3 pi over 4. From our chart, tan of an over 4 is 1. Now 3 pi over 4, this is where I would think, okay, 4 pi over 4 is here, right? Pi. So 3 pi over 4 would be second quadrant, because we're going counterclockwise, positive angles counterclockwise. You're in the second quadrant, which means tan is negative in the second quadrant. Okay, that's it for day 1.